Okay, so now I mentioned that trigonometry is related to circles. So when we saw that we measure angles, we can measure it using the distance traveled on a circle, which we call radians. So how do we get from defining these trig functions in terms of right triangles onto a circle? Okay, so let's go ahead and look at a circle. Okay, let me get my circle tool. Okay, so we're going to have this circle here. And let's say that we have inside of the circle, let's say we have an x-axis and a y-axis. Okay, so in other words, we're just drawing a circle on our coordinate system. Okay, so we have our x and our y-axis. Okay, well, okay, so and let's say that the circle is centered at the origin here. Okay, so at the point 0, 0. So this is the center of the circle. Now let's look at this line right here. What would this be? This would be the radius of the circle, r, right? It's a line from the center of the circle to the side of the circle. That's, by definition, the radius. So now if we think about, okay, well, naturally we can make a triangle out of this, a right triangle, by dropping these two sides. This is actually pretty similar to what we were doing when we defined the distance formula, right? If this is some point x comma y, right? We don't know what point it is, so just call it x comma y. This distance right here is x. This distance right here is y. Okay. So first of all, right away, we can get from the Pythagorean theorem, x squared plus y squared equals r squared. Okay. Now this equation, we haven't talked about this, but you might recognize this as the standard form equation of a circle. Okay, and this is where it comes from. Now what we want to do is we want to look specifically at a circle with radius 1. Okay, so we're going to change this radius to be 1. So we're specifically going to look at a circle with radius 1. And what do we call that circle? Well, what else would we call it but the unit circle? Okay, so because it has a radius 1, we call it a unit, the unit circle. Okay, so on the unit circle, let's look at this angle theta. Okay, well, sine of theta is going to be y over 1, which in other words is just y. Cosine of theta is going to be x. Okay, so we have a natural relationship here with the sides of the triangle and this angle on the unit circle. So we say cosine of theta is equal to x and sine of theta is equal to y. So one cool thing maybe we could see right away is that this means that cosine squared theta, which actually we write a little bit weirdly, we write the squared on top of the cosine. This is the same thing as doing cosine of theta squared, just FYI, plus sine squared theta equals 1 squared, or 1, right? Just making the substitutions with the Pythagorean theorem. So this is known as the Pythagorean identity. Okay, so now what we can do from this is that we can actually look at some common values of what the x and y values would be at specific values of theta. So in particular, some easy ones. What if theta is 0? Okay, if theta is 0, then we're going to be looking at the point right here, right? So the radius is going to be going right along the x-axis here. So it's going to be 1. So we're going to be at the point, because we're centered at 0, 0, and we have radius 1, we're going to be at the point 1, 0. Okay. So if theta is 0, then we're going to have sine of 0 is equal to the y value, because sine of theta is equal to the y values. So it's going to be 0. And cosine of 1, or sorry, cosine of 0 is going to be 1. Okay. You can put this in your calculator to confirm. And it doesn't matter if you're degrees or radians here, because 0 degrees equals 0 radians. But we are measuring in radians now. If we were to look at 90 degrees, okay, 90 degrees, we would be right here. So we'd be at the point 0, 1. Okay, 90 degrees, if you remember, is pi over 2 radians. Okay, so we're at the point 0, 1. So sine of pi over 2 is equal to 1. And sine of pi over, or sorry, cosine of pi over 2 is equal to 0. Okay. So we can keep getting some special points in this manner here. So some other special ones we look at, basically all the ones that I wrote down before. Pi over 4, 45 degrees, which is kind of like where this looks like it is right now. At 45 degrees, that's exactly halfway across this little arc of the circle, right? So that's where x is equal to y. So if x is equal to y and the radius is equal to 1, then Pythagorean's theorem would let us solve this. Okay. So in particular, if we have 1 and this is x and this is x, meaning that they're both the same number, x squared plus x squared equals 1 by Pythagorean's theorem. So 2x squared equals 1. So x squared equals 1 over 2. So x equals 1 over the square root of 2. Okay. We're only considering the positive number here. And sometimes we like to rewrite this as square root of 2 over 2, because sometimes some people don't like leaving square roots in the denominator. So whatever, this is fine too. So what this tells us is that sine of pi over 4, the y value is 1 over square root of 2, and cosine of pi over 4 is also 1 over square root of 2. Okay, so we're looking at the x values and the y values here. So we can do this with a lot of different angles. Other common ones are pi over 3 and pi over 6. Okay, pi over 3 being right here about 60 degrees, or exactly 60 degrees. Pi over 6 being right here, 30 degrees. Okay, so at those ones, I'll just write them down here because it's getting a little bit too much into triangles than we want to go. But sine of pi over 6 is equal to 1/2, and cosine of pi over 6 is equal to square root of 3 over 2. Okay, and pi over 3 is the opposite. Sine of pi over 3 is equal to square root of 3 over 2, and cosine of pi over 3 is equal to 1/2. So I don't want, we don't need to get hung up on all these values. If you ever need these values, I'll give them. some other common ones like sine of pi. So that's 180 degrees. That's going to be 0. Cosine of pi is equal to -1. So you can't have negatives if we think about the unit circle, right? Because pi would be halfway around the circle. So we'd be right here, right? So that's the point. -1, 0, right? So if you're in the second quadrant here, your x's are negative and your y's are positive. So that would be reflected in your sines would be positive and your cosines would be negative, right? In the third quadrant, they're both negative. In the fourth quadrant, sine cosine's positive, sine is negative. Okay. And these are also periodic, meaning that once you get to 2 pi, they're the same as they are at 0. And then you could keep going, right? You could go to 4 pi, and then you're back to this point again. So, they're going to keep repeating the values, and that's going to be reflected on the graph as well.